This is number 21 in our lesson 7.5 of our textbook on page 392, where we're asked to determine the type of symmetry that this graph has. So over here in the right corner, I've identified the three different types of symmetry that we have learned about. Symmetric to the x-axis, if you change the sign of the y, the x stays the same. Symmetry to the y-axis, if you change the sign of the x, the y stays the same. And symmetry to the origin, if you change the sign of x, the y also changes sign. So I'm going to start by checking for symmetry with respect to the x-axis. I need to substitute the opposite of y in for y. So this will become negative y, quantity squared. Everything else about the equation will remain the same. Well, when you square a negative, it becomes a positive. So we get x squared minus y squared equals negative 6. Notice this rule is exactly the same as what we started with. So it is symmetric to the x-axis. Let's see if it might also be symmetric to the y-axis. So to determine if it's symmetric to the y-axis, I need to replace the x with the opposite of x. So in my equation, I'm going to replace x with the opposite of x. Everything else will remain the same. Well, when you square a negative number, you get a positive. So you get x squared minus y squared equals negative 6. So when I substituted the opposite in for x, I noticed that the rule that I got after simplifying is still exactly the same as the original rule in the equation. Therefore, it's symmetric to the y-axis. Well, finally, let's check to see if it might be symmetric to the origin. If it's symmetric to the origin, then both x can change sign and y can change sign. So I'll take my original equation, which is x squared minus y squared equals negative 6, and I'm going to replace x with the opposite of x and replace y with the opposite of y. Everything else about the equation will remain the same. Well, when you square negative x, you of course get positive x squared. When you square negative y, you of course get positive y squared. And it equals negative 6. So again, notice the rule that is produced is the same as the original rule in the equation. So this is an example of a graph that is symmetric to the x-axis, to the y-axis, and to the origin.